Yar! This be a video about the general term of an exponential pattern. I'm your swashbuckling host, Mighty Beard, the terror of the sea. Sorry, everybody. I wish I could keep that up for a whole video, but it's never gonna happen. Maybe someday, if I keep practicing my pirate, I'll get there. I would like you to make a note as you go through this video. Please add it to your math notebook if you have it. Otherwise, like I've said before, please just add it to a lined piece of paper and that will do for now. You don't need to put the learning goal on there, but please do include a date and possibly an appropriate page number. But our learning goal, again, is to consider how algebra can be used to represent patterns, specifically exponential ones, as you probably guessed from the title of the video. All right, this is a reminder. You don't have to write this down. We wrote this down already another day. A linear pattern increases by adding or subtracting, and an exponential pattern is increasing by multiplying or dividing. Okay, and I shouldn't say increases by adding or subtracting or by multiplying or dividing. That sounds a little silly, but the pattern changes by adding or subtracting. That's probably a better word for it than increases. Okay, so the pattern's changing by multiplying or dividing. All right, you should write this down. This is just the general term for it. So an exponential pattern can be represented by this thing right there, which is some nice fun algebra. So hopefully you'll notice some similarities with our last video about linear patterns. Okay, so T1 still represents the first term in the pattern, okay, and N still represents the term number, all right, but in this case, instead of A, we're using R. Right? Fits with the pirate, doesn't it? We're using R to be the multiple of increase or decrease. Okay, so that's basically what you're multiplying it by. All right, and you can multiply to actually get smaller numbers. We're not going to do that in this video because it's a tad confusing to wrap your brain around at first. So we'll focus on patterns that increase. But you can still do that, and if you're super interested, please come see me in one of my office hours and I'll tell you all about it in great detail. Now, to find the general term of the pattern, we use the pattern. So I've just taken it from the slide before, so it's right there. Okay, so we first see what we have. So the first term in the pattern, that's our T1 here, is 3. Okay, this part shouldn't be rocket science. And the R is what it's going up by, okay, what we're multiplying by to increase to the next one or to get to the next number in the pattern, okay? And in this case, we're multiplying by 2. All right, if you're ever unsure of what that is, we talked about it last time, but I'll just emphasize it here. Just take one of the terms and divide it by the one that came before it, okay? So if we do 6 divided by 3, which is the first two terms, we do 6 divided by 3, that equals 2, okay? Which should be that multiple. Sorry about the messy writing. That's our multiple that we're increasing by, that we're multiplying by, okay? And if you did 24 divided by 12, you also get 2. Same thing with 12 divided by 6, right? So if you're ever unsure, and certainly there will be some examples, especially involving decimals, where it will be a little harder to tell, just take a number and divide it by the one before it. Okay, so then we substitute our numbers into this general formula. So the T1 goes right there, the R becomes a 2. Okay, and then what we're left with is this right here. So Tn, that means any term in the pattern, can be represented by filling in the information right in here. Okay, so that's 3 times 2 to the exponent n minus 1. Okay. And we can have a nice talk again during a meeting or office hours as to why it should be n minus 1 and not n, for example. There's very specific reasons that I'll leave out just for now. And again, our main purpose in doing this is not just to throw algebra in there, even though I think that would be reason enough on its own personally. But we are using that to then be able to find terms farther down the pattern. Okay, instead of having to write out every single thing in the pattern to get there. Okay, so if we wanted the 100th term in this pattern, this would be a much easier way to get it, than to double our numbers 100 times. Okay, and write all that out. All right, so if we're using the general term to find the value of the 8th term, whoops, that took things a little faster than I meant to. So we put the 8 in for the n. All right, so we want the 8th term in the pattern. And then we also put in an 8 up where the n was. Okay, so we're just substituting it in our formula like we did before, or like you do when using length times width, for example, to find area. Okay, and then we end up with 3 times 2 to the exponent 7. Okay, so 8 minus 1 is a 7. Okay, you can almost treat this like there's brackets up there, so you need to figure out that exponent first. Okay, so that's 3 times 128. Remember, 2 to the exponent 7 is not 2 times 7. Okay, just 2 times 2 times 2 times 2 is 7 times. Feel free to use a calculator for that one if you wish. Okay, and 3 times 128 should be 384. Okay, and then to find the 15th term, we do exactly the same thing, so I would like you to pause the video and give that a try on your own. Do that now. Okay, I'll assume you did that and it went very well, so remember you just put the 15s in where the n was, so you have 3 times 2 to the exponent 14, which gives us a grand total of 49,152. These exponential patterns can increase way faster than the linear ones did. Okay, so just be aware some of your answers might be big numbers. All right, next one. Write the first 3 terms of the sequence. Okay, and on the next slide, I will show you a way to shortcut this, but for right now, I want to just go through just to review how we're finding specific terms. Okay, so if you're just given the general term, remember, what we want to start with is T1. We want that first term. So you substitute a 1 in place of the n's. Okay, so we have T1 equals 2 times 1.3 to the exponent 1 minus 1. Okay, and then we work that through. And remember, if you recall from in our earlier unit, anything to the exponent 0 is equal to 1. Yes, exactly 1. So that means our first term will be 2. Okay, and then we do the same thing with the 2. You substitute the 2 in place of the n's, so we end up with 2 times 1.3 to the exponent 1, which ends up as 2.6. Okay, and then you do the same thing with the 3, substituting the 3 in place of the n's, right? Because we're wanting, again, T1 is the first term, T2 is the second term, T3 is the third term. Whatever number in there, just remember, is the position it is in the sequence or pattern. Okay, and there I go using the word sequence up there when you could mean pattern. For our purposes, same thing. So when you work your way through the math there, you should end up with 3.38. Okie dokie. Now, for a shortcut to that process. Now, this only works when we're finding some of the earlier numbers in a pattern, when you're asked to find the first 3 numbers or the first 5 numbers or something like that. This shortcut is useless if you're trying to just find a number farther down the pattern. So if I gave you this formula right here and said, find me the 20th term, what we're doing now won't help. Just substitute a 20 in for the n's and do the math. But if you remember, if you are finding those first few terms, just remember what the numbers in the formula represent. Okay, so I put it back up here, our kind of formula without the numbers in it. Remember that whatever's in that T1 spot is your first term, and whatever's in the R spot is what you're multiplying by to get to the next one. Okay, so because we know what our first term is, right, whatever's in that position, we already know that T1 equals 2. We don't have to substitute anything in for n, because by definition, because of how we're using it, all right, whatever's in that T1 spot before the multiplying sign, that's our first term. Now, we also know that we're we're multiplying to increase by 1.3 each time. So that means you can just take your 2 times 1.3, which equals 2.6. Okay, and then to get the third term, you just take your 2.6 and multiply it by 1.3. So to get each new term, you just keep multiplying by 1.3. Okay, so that may have been a little faster than the stuff that was on this slide from before. Okay, it's the same example. We found the same numbers. All right, but personally, I think this way is a little bit faster if you are only finding those first few terms in the pattern. Okay, so please try out the worksheet that I've included with this to give you some practice on it, and please ask me any questions by email or in our meetings or during office hours. Thank you very much for watching. Have a good day.